Hi, this is Nathan Tintle. In this Learning Goal video, we're going to talk more about power and how it changes. We're going to use the parapsychology studies example to talk about this learning goal. Remember that power is the probability you correctly reject the null hypothesis. That is, if the alternative hypothesis is true, that you conclude, hey, we've got evidence that null hypothesis is wrong. Power is a good thing. We want our study to have high power. We want this probability of making a correct decision to be high. So, what are the chances that if we did a Ganzfeld study with about 50 sessions, we would reject the null hypothesis? If we wanted to know that, in other words, if we wanted to evaluate what will the power be in my study, we need to do a two-step analysis. Let's look at that now. The first step in evaluating the power of a study is to figure out what value of the observed statistic, in this case a sample proportion, is going to be extreme enough, in this case large enough, to reject the null hypothesis. So if the null hypothesis is that these receivers are just randomly choosing one of the four images, then the null hypothesis says the parameter value is 25%. At a significance level of 5%, any sample proportion we observe of 38% or larger is going to be rejected. In other words, if at least 19 out of the 50 studies we look at have the receiver correctly identifying the image, then we're going to reject the null hypothesis and we're going to say we have strong evidence that in this Ganzfeld study of 50 sessions, there is evidence that the psychics are choosing the correct image more than 25% of the time. If, in fact, the observed statistic is less than 38%, we'll fail to reject the null hypothesis. Once we know where that critical point is, 38% or higher is going to be enough evidence, in other words, getting 19 out of 50 correct is enough, then we can go to step 2 to evaluate our power. Then we can ask ourselves, well, what if the alternative hypothesis was true? So here's two different values for the alternative hypothesis. In the first graph, the one on the left, you can see here that the probability that the psychic chooses the correct image is 30%. So we can ask, if the parameter value is 30%, what are the chances of getting at least 38%? Well, in this case, that happens about 27% of the time. Now, we're throwing around a lot of percentages here, so let me be clear. If the psychics are choosing the correct image 30% of the time, that's pi equals 30%, then the likelihood that we see 19 out of 50, that is 38% or higher in our study, is 27%. That's the power. The probability that we're going to conclude, hey, these psychics are doing better than chance, is 27%. On the other hand, if the true likelihood that the psychic picks the correct image is 50%, now we're on the graph on the right, then the likelihood that we get a number 38% or larger is quite large. In fact, it's about 97%. So for this study, the power would be 97%. Let's talk about three factors that impact the power of the study. First, as the true parameter value moves farther from the null value, we just saw this, as 30% goes to 50%, what happens to the power? The power increases. Second, as the significance level decreases, let's say we go from a 5% significance level to a 1% significance level. What does this mean? This means we need more evidence before we're convinced. We're going to need more than just 19 out of 50 to be convinced. Maybe we're going to need 20 out of 50 or 21 or 22 out of 50. What's that going to do to power? It's going to decrease it. It's going to make it harder to say, oh, I've got enough evidence. Finally, as sample size increases, power increases. A few words of caution. Power can be tricky the first time you see it, and we prefer you don't just try to memorize all those relationships we just talked about. Practice is really needed. It is a two-step process to estimate power. I think once you do a few of those problems, it starts coming a little more naturally. And the good thing is, you've already seen these relationships. Even though we didn't call it power, earlier in the course we talked about how as the sample size increases, as the magnitude of the effect increases, what happens? You get a smaller p-value if everything else stays the same. That's very much related to power. Power is the probability you can correctly identify an effect. As sample size increases and the magnitude of the effect increases, power increases. Significance level is a little trickier, but I think if you think about it this way, it can make sense. The significance level is a measure of how much evidence you need before you are convinced. If you go from a significance level of 5% to a significance level of 1%, it's saying, hey, I need more evidence before I'm convinced. If you need more evidence before you're convinced, that's going to make it harder to become convinced. Your power is going to drop.